For this part of Project 3, on the left hand side you will notice those are the pins that are actually coming from the Arduino Uno PIC that we have. The next two components are AND gates, where we had to wire certain signals together in order to manipulate 12 signals to operate 6 stepper motors. The next components in line that you will see are the actual relays. Instead of wiring up everything and cluttering up the board, we just actually used labels, so we just could bring it over. Over on this side you'll actually see how we actually laid out our relays and where they are compared to where we lined them up with the H-bridges. The H-bridges allow us to actually send a ground signal to shift the motor one way or the other to get us a plus 19 and a negative 19 voltage. That's what the relays were doing before. Here's an example of how we broke down our logic for what the controller was actually going to do on the PlayStation. L1, R1, L2, R2 are self-explanatory on the controller. DL is directional pad left, DR directional pad right, directional pad up, directional pad down, and then you can see X, square, triangle, and circle, and where we assign them to what motor. As we move along, you will actually see how we actually wired the PIC to what controller, what part of the controller. So A1 was wired to be circle, B1 was wired to be X. Due to the fact that we only had 10 outputs to work with and we needed 14 signals, we had to use some AND gates. Over here you will notice that we actually used the same notation along with the numbers that match from this side to determine how we were going to use the AND gates. For this phase of Project 3, we had to run a wire trace to figure out how to connect the two parallel ports, one coming from the actual motors and one coming from the actual board that we constructed. As you can see, we labeled all of the wires, including the pins that they should actually be going to on the parallel port, and we showed all of the colors and where they should be going to when we soldered them onto our board. The motors have their own male to female connectors. The colors do not match up. This is very important. If you wire it backwards, you will wire VC and ground to the wrong place.
Okay. See you.
Kolawali will now demonstrate the use of the arm using the PlayStation controller to show that our concept works. As you can see, it's kind of sluggish. That's due to the nature of how much amps it takes to actually push these motors and the weight of the robotic arm. And there you have it, a fully functioning robotic arm using a PlayStation controller.